Okay, so we are at 5.4 applications of exponential and power equations. Well, it's not 5.4 anymore. We got to change that. Now it's called 11.7. Anyway, that's the numbering system we used last year. Anyway, we are today talking about applications of exponentials. So basically, we need to write out our formulas. That's one of the most important things. And use formulas that are given to us. This is an example of, optional lame joke. Okay, great. Lieutenant Balumbo found this cryptic message containing a clue about where the stolen money was hidden. CIN to the 1 over 1/2. Oh, I think I know. All right. Do you know what power that would be? That'd be the second power. 1 over 1/2. 1 over 1/2. Instead of dividing by half, you can times by 2, so that's really a 2. And so then, yeah, Cincinnati. All right, that was really lame. Okay, moving on. Square roots and cubed roots. The square root of 16, of course, is 4. And don't think it's 4 and negative 4, it's just 4. We've talked about this. Then why on earth is this answer two things? Square root of 81 is just 9. Why is the answer 9 and negative 9? Because this is the absolute value of x. And that's really, really important. When you're square rooting a variable, that's where a lot of you are going to mess up on this next test. You're going to forget that you square rooted a variable, and you're going to not remember there's two answers. Sometimes it's better to, instead of using the square root thing, to go like this. To the power of 1/2 to the power of 1/2. It means the same thing. And when you do an even root, like the root on the bottom is an even number, then you need the absolute value. Final answer, x equals, and this is because you split it into two things, x equals 9, x equals negative 9. Now, a lot of people use this as a crutch, and they don't even know that there's an absolute value going on, and they just think, oh, so I put a plus minus on it. But what if the problem was this, x plus 3 equals 9? Then, do you have to make two equations and solve both of them? All right, I've been practicing that with you on the top 20 also, so you won't make that mistake. This means two equations. One of them is x equals 9, one of them is x equals negative 9, and yes, in this case, since there's no other steps, the answer would have just been plus and minus 9. Okay, now this is a really complicated definition of finding an absolute value. See how it says the square root of x is the absolute value of x? That's easy. And that means it's x if x is greater than or equal to 0, and negative x if x is less than 0. All right, so but basically what that means is it's trying to tell you what absolute value means. Do you get if it's a positive number in the first place? Then when you take the absolute value, it really doesn't do much. All right, and if it's a negative number, then of course it's going to be the opposite of whatever it was. The absolute value means your negative numbers have to change to positives, but if you're absolute valuing a positive, it doesn't change to a negative. All right, moving on. If you're going to do this, these have square roots in them. Are they going to have plus and minus answers? No, because they don't have variables. Remember, that comes in because you're doing a square root of a variable. These don't have variables. All right, so then you do a square root and then you cube it, and most of these. Sometimes you flip it too. Write down your three answers. These should be like easy peasy. If you know what's going on, write down these three answers. I'll pause for a second while you try that. All right, so you should have said square root of 9, 3. 3 to the third, 27. This one you should have said square root of 25, 5. To the third, 125. Make it negative 1 over 125. Raise your hand if you had that one right. All right, good. And this next one, fifth root. That means what times what times what times what times what? 5 times. We'll give you 32, and that's 2. And then you take 2 to the fourth. 2 to the fourth is 2 times 2 times 2 times 2. 16. How many of you had those right? Okay, good. Then, it's still called warm-up. This is more warm-up of the warm-up. This is a review that would help you for this little quiz you have to take today in class. You're actually taking it finally. And it's got some solving in there. Do you get that this has a root and it has a normal power? I personally think it's easiest to write these as a fraction exponent then. It's either 4 over 9 or 9 over 4, and it goes based on roots go on the bottom, and therefore what? 9 over 4. Now, did I solve it? No. I just made it easier to solve. Because now I can tell, oh, I just have to put this to a power. And I put it to the power of what? 4/9. Okay? So then, if I'm allowed to use a calculator on this, notice this says round to 2 decimal places. My calculator can do the 9th root of 516, right? I wouldn't want to have to do that. So this is the part where you'd put it in a calculator. But the calculator is not smart enough to catch the whole plus minus thing. Did we just do an even root to this? No, we did an odd root, so we don't have to worry about it. But a lot of you probably weren't even thinking about that. If we had done an even root, we would need to have plus and minus on our answer. But it's an odd root. So we just have to do 516 to the 4/9 power. You type in 516 power of caret. If you say 4, it's going to right away put 516 to the 4th power. We don't want that. We want 4/9. Yes, 4/9, like that. 516 caret, parentheses, 4/9. Okay. Yep, I'm sure it is. And you round it to 2 decimal places. Sir.
Okay. Now you want to like booster pack.
Yes. You give me some collateral, and I'll be glad to let you borrow that. Okay, so Mr. Q, what did you get when you typed in 516 to the power of, parentheses, 4/9? 0.055. Now, did you round to 2 decimal places? Not yet. So 16.055 would round to 16.06. That would be 2 decimal places. How many of you had that for your answer? Okay, good. This next one, just think of this problem right here as a problem that you could do the normal way, except you're going to have trouble in your head dividing by 5 on both sides, because 270 divided by 5 is a pain. We'll use the calculator for it. And then, once you got the 5 off of there, you'll have to put it to the power of 1 over 3.25. Again, not going to be able to do that in your head, but you can use the calculator for that. So once you get 270 over 5, then you can put it to the 1 over 3.25. Make sure you have it in parentheses, or your calculator won't like it. Okay, some of you don't have the calc out yet. You'll need one. Borrow one. I have extras if you need it. Yes? Okay, good question. Since we put it to a root, it is a root, but that is not an even number, and therefore we don't have to worry about the whole plus minus thing. Okay? Very good question, though. Okay. So really what it comes down to is you get your calculator, you divide 270 by 5, and 270 divided by 5 is 54, thank you. And then the 54 gets put to the power of 1 over 3.25. Save me some time. What's that one? 3.41. Anybody verify that? Okay, good. All right. And if you had trouble putting that in, it's probably because you didn't put parentheses around this guy. 54 caret, that thing in parentheses. Okay. Simplify this one. All right, so if you're simplifying these, that means you can't get the answer. The answer is not like 4. You can simplify it, though, as in you can put each of these numbers, it's kind of like distributive, to the 2/3 power. And do you remember how to do a power to a power? All right. So when you're all done, whatever 25 to the 2/3 power is, I can do it in my head. I don't know if you can. 125 to the 2/3. And the other part of the answer is x to the 5th to the 2/3. Kind of like distributing it. And then this would become cube root of 125 is 5. 5 to the second is 25. X to the, What would you put? How do you multiply 5 and 2/3? Put this over 1. Now multiply the tops, multiply the bottoms. 10 over 3, 10/3. What if somebody said 3 and 1/3? That's the same as 10/3, right? I'd have accepted that. I think isn't it 3 and 1/3? I think it is. Okay. All right. So this is a good answer. Or if you had to use a decimal, since calculators were allowed, I probably would allow just say 1.3 repeating on that one. All right. And the last one, all by yourself, without any prompting from me. Try this one, and then check it with the kid next to you. I want to do one more practice. Actually, I think this is enough practice problems. And then I'm going to show you the one thing that's new for today. Other than using your calculator a lot, there's one new thing. Pause while you finish this one up. Okay, here's what I'm thinking that you should have been thinking. 16 to the negative 3/2. First of all, square root 4. 4 to the third. Quiet, please. 4 to the third. 64. Then you make it negative. 1 over 64, isn't it? Okay. Then I have this x to the negative 4 to a negative power. And this get multiplied. I just showed you a second ago how to do that. You put this over 1, and then you multiply the tops, and you multiply the bottoms. The tops will become positive 12 over 2, which makes 6. So if I'm going to have an x to the 6th, I have two options. I can put it, if it's x to the positive 6, right? Then on the top, it'd be x to the 6. Or if I really wanted to, I could put it on the bottom and say x to the negative 6. But that'd be dumb, because then I just have to simplify it again. Because you can't leave your answer with a negative in it. So there's your final answer. All right. Questions? Yes? Good question. Is this the same exact thing as that is? Yes, they are both the same, and they're both okay. Sorry, thank you. Yes, now they're both the same. Good point. Okay, and that is important. If you see this all the time in algebra, and you need to get that that's the same as a fraction n. And what fraction is it? 1/4 n is the same thing as n over 4. Yes?
Why was it 4 or 6?
Okay. Multiply the tops. Tell me what you get. There's the problem. You were thinking it was an 8. It's not an 8. What's 4 times 3? Okay, one thing at a time. Do you agree that it's negative 4 over 1 is the same as negative 4? Are you with me there? And then this negative 3 over 2? Negative 3 over 2. Do you get that that's what you're really multiplying? So then don't cross multiply. There's no such thing. No. You multiply across the top and multiply across the bottom. Okay.
Wait, but then why was it?
This is why I hate writing fractions diagonally like that, because you weren't sure exactly what we were multiplying. If you write fractions like 4/5 like this, it's much worse. Writing this 2/3, if it would have been like this, 5 times 2/3, it would be much more clear that I was multiplying the tops and the bottoms. Okay, I was not cross multiplying there. Just multiply this way and that way. Okay? All right, good. No problem. Thanks for asking. I would much rather have you ask. All right, so now, what's new? We need to teach you the new stuff. The new stuff isn't super hard. It really isn't. We've already practiced enough with those. The new thing is to take problems that are using these, that are using these formulas and solve them in different ways than we ever have before. I am not going to do that one. I'm going to do this one. Detroit's population has decreased 25%. And by the way, it is true. Detroit has really dropped a lot. And they're actually, it's really rough in their inner city. They have, a lot of their houses are being torn down. And some of them are, a ton of them were sold for $1 a piece. And you might think, well, why wouldn't everybody want to buy them for $1? Because the deal was, if you buy it for the $1, then you have to fix it up. and make it a decent house again. And it might cost you 50 or 70,000 to get the house repaired enough so you could actually live in it again, because they were in such rough shape. So you had to have the money to be able to fix it up. And the ones that were really, really bad, they just bulldozed them down. So they have some neighborhoods that literally are like, just imagine your neighborhood if 3/4 of the houses were bulldozed down, and it's just a house here and a house there, and a house there. It's really kind of scary. Yes, they would. You don't get to choose whose house gets bulldozed, though. That's a different thing. Okay, so anyway, write an equation for this situation if their starting population was 2 million to begin with. All right, do you get our starting number always goes here? Then the new thing I have for you that you need to understand, this is always 1 plus or 1 minus. And what are we talking about? Growth or decay? Decay, so we go minus. And it says 25%, so I go minus 25%. And x is how many years? Well, in this case, I have an x here, right? And how many years is it? 10. And the starting value is 2 million. You don't have to write all of this. I'm just trying to show you, you already know this. Your start value here, this is always 1 plus or minus the decay or the growth. That's all same. And the x is just like it's been 10. If I wanted to put a 10 in, I could put in a 10. If I wanted to find out 5 years, I put in a 5. What's new now is that you have to understand that this is where the end value goes. So if I told you that Detroit's population is going to end up, we're not going to do this problem, I'm using this as a framework, okay? If I told you Detroit's population was going to end up, starting at 2 million, ending up at 1 million, if I put 1 million here, you could solve then for the one thing we don't know. Do you get how this has only one variable in the whole thing? Which is x, okay? So if I tell you, I'm going to give you one, the gas price a year ago, 1 year ago, was $3.79. Now it's 1 year later, and it is about $2.07 a gallon. Obviously, that's been a decrease, right? How could you do this with an exponential equation? Yes? Question? Nope, not going back to the last one for right now. Sorry. Stick to this one, and then if you still have the same question on this one, I'll answer it. Got to move fast because it is shortened day today. Okay, so do you get how these always have the starting value here? Of the 379 or the 207, which one came first in real time? Which one did it start with? 379 goes here then. Okay, and then this is 1. And is this growth or decay? Decay minus. Do I know what the growth decay kind of rate was? If I don't know what it was, you put a variable. You with me so far? And do I know how many years it was so I can put in my x? Yes, I do. I know how many years. It was 1 year later. Boom. Now, what number doesn't have a home yet? The 2.07. And remember how I was saying this is the start and this is the end. And so the end is 207. That means I've got everything I need to solve an equation. I just got to solve for r now. Get the r alone. All right, so I'd like you to solve this one. I've already written it for you. Solve it. The first thing you do is the power, and power of 1 doesn't really do anything. There we go. Now solve it. I'd start by dividing by 3.79. You could multiply it up in, makes it a lot harder, but personally, start by getting rid of the 3.79. Divide by 3.79. Cancels. This comes out to some decimal. Somebody help me with that. What's that? Yes? What'd you get? 0.546. Can anybody verify that? Okay. And word around, it doesn't say, so better to be a little more accurate and use 546. And then 1 minus r. What am I trying to get alone, the 1 or the r? The r. So I'm going to subtract 1 and r will almost be alone. Then this becomes, let me think, 0.454? You have a calculator, I don't. Give me a break. Okay, equals negative r. And then, how do you get a negative off something? Hold on. Negative. This wasn't negative. There was no negative there. Oh, you're right. I'm sorry. Then I subtracted 1 and it became negative. Sorry. You're right. Okay, so then I'm going to replace this with, or multiply by negative 1, means I'm going to finally get an answer that is positive, 0.454. Now, I know some of you are going to say, in this case, couldn't I have just divided these two numbers and then, like, subtracted that from 1 and got the answer? Yeah, that would work on this problem. But the thing that was special about these equations is you can do them even if it was 10 years later. All right, I'm going to do that with you right now. I think this will be a good real-world problem. When I went to St. Olaf, the cost of tuition was just, for my starting year, was just under $10,000. We're going to go with $9,900 for tuition, room, and board at St. Olaf College. It seems impossible. Frankly, back then, my family felt like that was a lot of money. Okay, and nowadays, you guys just looked up prices at colleges. That's like incredibly cheap compared to nowadays. Okay, that was the old price. The now price is $52,000. Okay, now the question is, really, how much percent did it go up all that time? That's exactly right. I need to tell you how many years that is. I graduated from St. Olaf, or I started this, to be fair, I started at St. Olaf in 1986. So this is in 1986. How many years has it been to the year 2015? 29 years. Holy crap. All right, let me make sure that he's right on that. 29. So, yeah, I think he's right, isn't he? 29? All right. So then, if it's been 29 years, how much percent did it go up on average each year? So you write yourself a little formula. You go y equals the starting value, 99. You say 1 plus the rate. Oh, wait, yeah, this was a plus, right? Yeah, tuition was definitely going up. Okay, and then how many years was it? I don't put an X here, I put a 29. And then what's the new thing for today? Really, the new thing for today is you can put a variable here if you don't know it, and you can put the ending here. Solve that, and you'll know what, on average, the tuition went up per year, on average, every year. You solved it already, or you got a question? Yes, you may. All right, so to start with, you're going to, how do you get this 9,900 off of here? Divided by 9,900. Divided by 9,900. Okay. Now, I need somebody, oh, actually, I can do this. I got a calculator up here. 52,000 divided by 9,900. Hold on just a second, please. I want to do this myself. 5.2525. And now, that's not the final answer. Okay? We got to go a little further to get that. This is 1 plus r to the 29th. How do I get that 29 off of there? Put it to the power of 1 over 29. So 5.25, 25, 25, etc. I'm going to actually clear that off and round it to 5.25. It does mean my answer is going to be a little less accurate, but 5.25 to the power of parentheses 1 over 29 1.0588. I'm going to actually be a little more accurate on this one because I'm close to my final answer here. Equals 1 plus r. I'm not quite done yet, am I? So now I got to subtract 1 from both sides, and I think you'll see the rate shaping up here pretty easily. 0.0588 equals r. Do you see why we used about 6% for our growth factor for colleges? Because over the last 20, how many years was that? Holy crap, that's impossible. But anyway, since I went to St. Olaf, it's gone up about 6%. 5.88. Yes?
Do I have to write out the
It depends on what the question asks for. But that is a decimal. It's not a percent. If I want a percent, I move the decimal over 2 spots. Here's a better approximation. 5.88% on average. And they've actually slowed down their percentage increases lately, but it's still going up, pretty healthy. It's way above. How do you compare it with other things? Well, we could look at the gas price over that time and see what was the gas price in 1986 and what's the gas price now. See if gas prices have gone up a lot or a little. You could look at real estate costs back then, like buying a house. Same house then, same house now. See what percent it went up. See if our price of St. Olaf went up at the same rate as everything else, that's fair. You don't expect cheeseburgers to cost $1 50 years from now, right? They're going to cost more because there's always inflation. Yeah. Yes.
Getting more advanced equipment rather than doing the same thing. With burgers, you're not.
I hear you. I get you. Gas is gas, and it didn't change any over that time, right? And if you're buying a computer, you're getting a better computer. It's okay. Getting a better computer versus an old computer. You're right. You're getting a better thing. But still, if you're getting the base computer nowadays compared to the base computer a long time ago, then it's kind of a fair comparison. You know what I mean? Because if you compare a really expensive computer now with a really expensive computer back then, it might be harder to compare because the really expensive computers now have just so much more. Like, did you know that they launched nuclear weapons with things that were far less advanced than your iPhone? Think about that. that is pretty scary to think that you've got that much technology in your pocket. That's way bigger than a room full of computers that was used to, like in the Cold War against Russia. Your iPhone, if you transferred it back in time, would be like the ultimate weapon. They could use it if they wanted to. It would. It could do. I mean, I know what you mean. It would need the internet. But like, if you could get a glimpse, just to think of it this way, if you could get a glimpse at what some kids like you 50 years from now are carrying in their pocket, can you imagine how valuable that would be to Steve Jobs, or because he's dead, so he wouldn't care, to somebody who's alive in the technology industry, Tim Cook, for example. Can you imagine what they would pay to see what 50 years from now devices have got on them? Oh my gosh. Okay, anyway. I'm sorry. I'm sure it's awesome, but we got to move on. All right, so our homework, the first 7 questions of our homework are just like this. I want to do the first ones with you. Everybody find your homework for today, and it's under lesson 7, and it's right here. I want you to, on today's, we've done a lot of review lately, so what I'm going to have you do is problems 1 through 7 is very good. We need to do all of those. And on the reviews, you can do the even letters. Do you get what I mean by that? The even letters. B, D, F, or H. So in other words, the odd ones would be A, C, E, G. You're doing the even ones. You're doing B, etc. So if you want to just cross them off, start by crossing off A, and then cross off every other letter after that. Get the idea? All right, so that's just a little cutting your assignment down to make it more reasonable sized. And the first few questions, let me start with you, okay? All right, so I'm going to download this file so I can see it in a little larger format. And here we go. The cost of a 20-ounce box of cereal has increased from $4.25 to $5.50 over 5 years. You start with y equals the starting value, $4.25, times 1, and it's an increase, right? Plus, do I know the rate? No. Put an R. And then what do I put it to?
5.
The 5. And then the one thing that doesn't have a home until today was the end value, the current price, 5.5, 550. And then you solve this little equation. Okay? Remember to always start by dividing by the number in front of the parentheses, 4.25. And then at the end, you're going to have to put something to the 1/5 power. And again, the calculator is pretty handy for that. So on this one, just to help you a little further, 550 divided by 425. $1.294 equals 1 plus r to the 5th. Now I got to put both sides to the 1/5, and that's where your calculator is going to start coming in really handy. So you put that 1.294, and frankly, I wouldn't even round it. I'd just leave that in your calculator and then say to the power of 1/5 in parentheses. And I came up with 1.0529 equals 1 plus r. So then you just have to subtract 1 from both sides. And I have my final answer. R equals 0.0529, and I hope you know what percent that is, 5.29%. If you had said 5.3%, I'd have been fine with that. It did not say, oh wait, it does. Round to the nearest hundredth. In case you can't see it at home, it says hundredth there. That is the hundredths. The hundredths is that spot. Okay, so you need 2 spots, 2 decimal places. Hundredths is 2 decimal places. Tenths is 1. All right, the next couple are a lot alike. Just wanted to get you this idea that you could put the ending number here and solve for the rate. All right, and the rest of it is all review. And that's all I have for you for today.